Okay. All right. So mixed, Claisen condensation. Okay. So mixed condensation kind of actually less useful. Okay, because you generally kind of mixture. Okay, has a lot of kind of product inside. Okay, but pretty useful for the kind of exam quiz. Okay. All right. So because that's kind of good way to learn how to draw the Claisen condensation product. Okay. So for example, okay. So and use another maybe here. All right. So we try to if you have any question, you can type in the chat window. Okay. So we try to do the Claisen condensation for these two esters. Okay. So because the esters kind of OMe. Okay. So we use sodium methoxide as kind of base. All right. Okay, so let's come to problem, okay, because we have two kinds of alpha carbon, okay, so that's alpha carbon 1, alpha carbon 2, and also two kinds of carbonyl, okay, so the C1, C2, okay. So in this case, you can have all the combination, all the possibilities, okay. Eventually, you should get kind of the full product, okay. Right. So that's the way how do we do kind of the mixed Claisen condensation product, okay. So so first kind of I do this with alpha carbon 1 attack kind of itself gets another the first carbon, okay. So that's should give you I just go ahead and draw the pretty one, okay. So but if you guys have time, okay, so try to practice on it, okay. Right. So this is the new bond formation, okay. So positions, okay. All right. So that's the alpha carbon 1, okay, and then this is carbonyl carbon 1, okay. All right. So alpha carbon 1 can also attack now this second ester, okay, so C2, okay. So this time, okay, so I also draw kind of the pretty one, okay. And okay. Okay, so this part from kind of second ester, okay. And you can also do this alpha carbon 2, okay, attack now itself, okay, alpha carbon 1, carbonyl carbon 1, okay, carbon 2, okay. All right, so that's it's reactive itself, okay. So what happens kind of something like this, the product. Okay, so the new bond positions here. And then last one is kind of the alpha carbon 2 attack carbonyl 1, okay. All right, so new bond position, okay. And then this time, okay, so because it's kind of the C1, okay, so that's use different control, okay, so okay, so that's how do you do the kind of mixed kind of the Claisen condensation product, okay. So we'll do some kind of practice on Thursday, okay. All right. Actually, for reality, definitely we don't want kind of this mixed kind of Claisen condensation product, okay, because it's kind of just mass up, kind of a bunch of we call the beta ketone esters, okay, so that's hard to separate it because all of them have kind of similar property, okay. For reality, okay, so if we use kind of have to do kind of mixed other Claisen condensation, okay, so what we need to do kind of just use the ester without alpha hydrogens, okay. So so this ester will only contribute, okay. Probably, okay. So depends, okay. So we'll have kind of the quiz 6 first, okay. So and next exam kind of maybe next week or maybe the following week, okay. So because we don't have kind of quiz 7, we can have a little bit of flexible schedule, okay. All right, okay, come back to the class, okay. So for the mixed Claisen condensation, if you want to get only one product, okay, so normally you use ester, okay, so without kind of alpha hydrogens, okay. So in this case, this ester can only contribute kind of carbonyl carbon and the leaving group, okay. So those ester, yeah, for example, yeah, this is the benzoate kind of ester, okay, and this one's kind of diethyl, yeah, carbonate, okay. So that's and last one kind of the diester, okay. So those has no alpha carbon, that's cannot contribute kind of alpha, yeah, cannot alpha carbon kind of do the kind of at the nucleophile, okay. And then the another compound, normally we choose oh, I'm sorry, okay, yeah, that's right. So forgot to share. All right, okay, so can you guys see the PowerPoint? All right, okay, thank you. Yeah, sorry, okay, so yeah, for the mixed classic condensation reaction, okay, so we use kind of here the ester without alpha hydrogens, okay, also actually without alpha carbons, okay. And for example, this is the benzoate ester, and also this one called kind of here the diethyl carbonate, okay, so it's also ester, okay. And then the last one kind of also the ester, okay. So those the cannot use that kind of nucleophile, can only contribute kind of the carbon and also the group, okay. And another region, okay, so normally we can use the ketone or kind of the nitrite compound, okay. And so those compounds only contribute kind of the alpha carbon, okay, as a nucleophile, okay. There's no leaving group, okay. So in this case, when you carry the mixed Claisen condensation reactions, okay, so you should get kind of only one major product, okay. So that's something keep in mind, okay. But for the exam quiz, okay, so sometimes I do test you kind of the mixed condensation, okay. So it has 2 alpha carbon, 2 kind of carbonyl carbon, okay. You should be able to draw all the product, okay. All right, and for the Claisen condensation reaction, okay, once the reaction is done, okay, so you generate the reaction product called kind of the beta ketone ester, okay. All right, beta ketone ester we learned it before, okay, so like acetyl acetate ester, okay. So this one actually kind of we can do the decarboxylation, okay. So that's showed here, okay. Claisen condensation, we get kind of the beta ketone ester, and then you do the saponification, okay, and then that's hydrolyze the ester into kind of carboxylic acid, okay, and then you just heat it and then kind of acid conditions, okay, that's give you kind of the decarboxylation product, okay. So eventually you get ketone, okay, and so one property for the beta ketone ester, okay, so actually kind of it's also can do the acylation, okay. So for example, this is the product, okay, so you can do kind of remove the beta hydrogens, okay, and then do acylation, put another acyl group on, okay. So that can make all kinds of product, okay. So that's why that's why I said kind of for this chapter kind of reaction much more complicated, okay, because there are kind of multiple kind of reactions, okay, reaction tandem, okay. So for example here, okay, so the tandem reaction happened kind of the first step, okay, we do kind of the Claisen condensation, okay. All right, we generally kind of the some kind of the beta ketone ester, okay. All right. So beta ketone ester actually kind of if you like, okay, so you can also put some kind of acyl group on here, okay. So the next step, okay, so we can do the alpha the acylation, okay. Okay. Right, and then you can put acyl group on, okay. So doesn't matter, okay, you can put 1 acyl group or 2 acyl group, okay. And then the third step, okay, so you can do kind of the saponification followed by kind of decarboxylation, okay. Pretty much in the end, okay, you generate kind of the ketone, okay. So let's see just here. So by this strategy, okay, so pretty much you can make all kinds of different ketones, okay. So that's the quite useful synthesis strategy, okay. So the different from kind of acetyl acetate ester, okay. So pretty much you only make kind of methyl the ketone, okay. But this one, pretty much any ketones, okay. Right, and then here's some kind of example. Actually, kind of I use this example is from kind of the last question of the discussion worksheet of chapter 19. Okay, so chapter 19. Yeah, okay, so yeah, remember, okay, ask you kind of design the synthesis route. Okay, yeah, to make this ketone from ester. Okay. All right, so so at that time, okay, so yeah, we can use the chapter 19 and the question reaction to do it. Okay, so remember, okay, so we convert first do the hydrolysis, and then do the kind of the cyanide chloride convert kind of the to acid chloride, okay, and then eventually use the copper reagent, okay, should be that's can give it kind of ketone, okay. Here, okay, actually kind of we can still use the same starting material, okay, but use chapter the 20 question reactions, okay. So finish this pass, okay. All right. So what we can do is kind of first do kind of Claisen condensation, okay. All right. So just the 2 ester, okay. Still do here, okay. OET actually kind of this way. All right. We generate kind of Claisen condensation product, okay. And then following we do acylation, okay. So acylation kind of pretty easy, okay. So yeah, this one is sodium ethoxide, okay. So yeah, here we still use sodium ethoxide as base, okay, and then use the methyl iodide, okay, as a substrate, okay. So that's we put a methyl group on here, okay. Yeah, right. Right. That's methyl group, okay. And then following case, so we can do the kind of spondification and also the decapsulation, okay. So that's I just drew the 2 reaction condition all on the MIR, okay. The first step case spondification, sodium hydroxide, okay, with water, okay. Water. And second step case just kind of the acid condition with some kind of heat, okay. Right. So the second step, okay, you cleave forward all the kind of the ester part, okay. So eventually you get kind of same ketone, okay. Yeah. So that's also means the actually with more and more reaction you learn in organic chemistry too, okay. So you should able to kind of the design synthesis route, okay. So the from same starting material, but the different kind of reaction, okay, get actually kind of the same targeted molecule, okay. So when you get time, okay, try to summarize the old kind of method, okay. For example, the old method we learned so far how to prepare amine, old method we learned so far how to prepare ketone, old method we learned so far how to prepare capsaicin, okay. That's actually kind of a pretty good way for you to learn the organic chemistry reactions, okay. Right. Okay, so now we move to the fifth reaction, okay. So in this chapter, okay, called the micro addition, okay. This is also a named reaction, okay. So micro addition actually kind of the note hard, okay. So pretty much you just think about kind of alpha carbon as a nucleophile, try to do the kind of the 1,4 addition to alpha beta unsaturated ketone or aldehyde, okay. So that's we have to little bit the review the 1,4 addition, okay. So that's actually kind of chapter 18 reaction, okay. Chapter 18 reactions case where if we have some kind of weak nucleophile, okay, so like the amine or kind of a copper reagent, okay, so react with kind of conjugated ketone or aldehyde, okay, so conjugate aldehyde, okay, and then are kind of 2 situations, okay, so depending kind of how strong nucleophile can do 1,2 addition or 1,4 addition, okay, and the 1,4 addition we said 1,4, okay, actually kind of looks like a 3,4 addition, okay. So that's 1, 2, 3, 4. Okay, so reaction happen like this way. Okay. Okay, this one goes kind of the oxygen. right? And then this oxygen pick up the hydrogen, okay? So generally kind of the eno, okay? Right. So eno, we know that kind of non-stable, quickly determines kind of into the ketone, okay? So eventually this hydrogen shift to here, okay? So the final product of something like this. Yeah. So that's why we call kind of looks like 1,4 addition. Okay, so one. Okay, so that's here 1, 2, 3, 4. Okay, 1,4 addition. Okay, but eventually product actually look like a 3,4 addition. Okay, so that's 1, 2, 3, 4, 3, 4. Okay, so hydrogen and also nucleophile attack kind of the third and the fourth carbon. Okay, so that's here. Okay, so the chapter 18 reaction we learned. Okay. And so for the micro addition, pretty much this alpha carbon, okay. So this nucleophile become kind of alpha carbon, okay. Try to do kind of the 1,4 addition, okay. So actually kind of looks like 3,4 product, okay. And so general reaction showed here, okay. Yeah. So here just kind of ketone as the nucleophile, okay, and then react with kind of alpha beta unsaturated the ketone aldehyde, okay, also fine, okay. Okay, so we still use another color chalk. Okay, so for this reaction case, we have normally you still use the sodium methoxide or sodium kind of ethoxide as kind of a base. Okay, so I just put R here. Okay, and then this alpha carbon, okay, attack on this the carbonyl carbon, okay, and give you the final product, okay. Okay, so I just use blue color, green color, highlight kind of the new bond formation. Yeah. And not only the ketone can use that kind of nucleophile, okay. So other kind of the species as well as contribute kind of alpha carbon can do the alpha beta unsaturated kind of micro addition, okay. So like nitri and nitroarchene or ester, okay. So that's I will give kind of example later, okay. Right. For this reaction case, so actually the reaction mechanism is also required case. So also required case. So one way showed on the kind of PPT file, okay. And here I will show you another way to do it, okay. So it's a little bit different, but the overall should be same, okay. Right. So some kind of base coming, okay, pick up here the alpha carbon, okay. And then you generally kind of enolate. Okay. All right, so you can also draw the kind of enolate on the kind of similar like that's right, okay. So loose double bond, okay. The reason for that one, that's why we call it an addition, okay. So one carbon pick up the alpha carbon, another carbon, okay, pick up the hydrogen, okay. So that's 1,4 addition. So when we said 1,4 addition actually kind of looks like 3,4 addition. This one becomes saturated, okay. Okay, so that's the enolate ion. Okay, so enolate ion you can also draw the same thing. Showed on the kind of screen. Okay, here. Okay, and then on screen kind of the shift electron twice. Okay, so for the addition of the two alpha beta unsaturated ketone. Okay, so but you can also draw this way. Okay, so don't need the shift. Okay, only shift once should be enough. Okay. Right, so here this guy. Okay, attack kind of the last carbon. Okay. All right, and then why there's only one hydrogen showing the first molecule? Actually kind of three hydrogen, okay. So you connote dipronate kind of all three together, okay. You do it one by one, okay. So only dipronate 8 and 1, okay. Yeah. Okay. Right. So this one attack kind of the fourth carbons, okay, and then you shift the electron like this, okay. you can add a lone pair electron, okay. All right. And then yeah, falling kind of just this reaction normally done in kind of alcohol solution, okay. So yeah, this O minus pick up proton from alcohol, okay. And then give you kind of the way we call kind of eno, okay. Right. So eno can quickly totalize in kind of ketone, okay. So that's give you kind of final product, okay. Yeah. So the people said kind of where the hydrogen goes, okay, that's actually hydrogen kind of go to this carbon, okay, go here, okay, maybe right you guys here, okay. So that's the whole process, okay, for for micro addition, okay. So yeah, for you guys, okay, so yeah, you only need to know how to draw until the eno, okay. So yeah, eno keto, the totalization, okay. So actually not required, okay. So as long as you know, general kind of eno, that's fine, okay. So for for the micro addition case, so alpha beta unsaturated kind of product can be ketone or ester, also can aldehyde, okay. And then for the nucleophile, okay, so nucleophile can be all kinds of diverse, okay, very diverse, okay. So the nitrite compound, okay, so ketone, ester, or kind of even some kind of other I will show you guys, okay. So right, for example, okay, so last year we have kind of this is the acetyl acid ester, okay, as a nucleophile, okay. So we know that the middle carbon has kind of very strong kind of nuclear facility, okay. So because this has kind of relative acidity, okay. And then the substrate, okay, so that's kind of alpha beta, the unsaturated kind of ester, okay. So that's ester, okay. And then after reaction, okay, so you can generate kind of addition product, okay. And then the second one kind of we use malonate ester as a nucleophile, okay. So that's here, okay. And then attack an alpha beta unsaturated kind of cyclic ketone, okay. So that's also at here, okay. And the last one kind of even more interesting case. So this time case, so no carbonyl compound case. So as kind of the conjugate kind of the nitrate compound at the substrate, okay. So and then another kind of ketone as a nucleophile, okay. And then this ketone conjugate kind of alpha carbon, okay, attack kind of the fourth carbon on kind of conjugated the nitrate, okay, and then give you kind of final product, okay. And so give you another case. So not only the carbonyl compound case. So as well as kind of two electron join group okay, attach kind of on same carbon can use that kind of the alpha carbon case. So for example, give you another example, okay. Right. So we have this alpha beta unsaturated kind of ketone, okay, and then react with kind of the dinitrite compound, okay. Dinitro compound, okay. So nitrile group, okay. So that's the alpha carbon because these two group kind of strong electron join group, okay, and then make this carbon kind of one nuclear facility, okay. And then apply some kind of the base, okay, sodium methoxide, for example, okay, this time, okay. Right. So once reaction is done, okay, so keep in mind, okay, the nucleophile attack on the fourth carbon. That's fourth carbon, okay. So 1, 2, 3, 4, okay. Okay. And so for the hydrogen case, so normally you don't need to put on, okay, but if you want to put on here, that's okay, okay. So that's the 3-4 addition, okay. The last kind of that's kind of show you all the possible regions for the micro addition. Because micro addition actually kind of it has much more broader kind of region. Okay, so for the nucleophile case, so you can use kind of the alpha beta carbonyl kind of ester, okay, so beta the ketone ester, okay, or kind of this the beta diketones, okay, or even kind of this nitro kind of ester, okay. Dinitro compound or kind of the nitrite compound, okay. So that's the all kind of good the alpha kind of nucleophile region, okay. for the conjugated, for the kind of the electron files, okay, so yeah, as long as kind of the yeah, theta bond conjugate with kind of electron rejoin group, okay, can be used that kind of the yeah, substrate, okay, also kind of the yeah, we call kind of electron files, okay, right? So can be kind of conjugated nitride, okay, conjugated kind of the ketone, conjugated kind of ester, conjugated aldehyde, conjugated kind of the yeah, nitro compound, okay. So yeah, all kind of variations, okay. And this reaction kind of actually kind of yield pretty high. Okay, so I did yeah many times. Okay, so pretty cool reactions. Okay, so yeah, you can build a very complicated molecule. Okay, and overall this reaction is not hard. Okay, so but the yeah, quite surprised. Okay, so in exam quiz, okay, a lot of students kind of the yeah, get wrong answers. Okay, for these quite reactions. Okay, the key thing. Okay, so yes here. Okay, so yeah, make sure that the yeah, find the yeah. Terminal kind of the yeah carbon 4, okay, so yeah from conjugated yeah the yeah system, okay, and then alpha carbon from nucleophile, you build bond between these two guys, okay. All right, give you guys yeah one example, okay. Yeah, quite often happen kind of yeah the student kind of count yeah, the wrong number of the carbons, okay, for the yeah for the micro addition, okay. All right, so we have this one, okay, plus yeah. All right. So quite often happen that the student don't recognize this kind of the micro addition. Okay, so think for example maybe the yeah auto condensation, accumulation, or kind of the yeah ester yeah the yeah Claisen condensation. Okay, so yeah the easy I recognize kind of the yeah micro addition kind of there's yeah the C theta bond, okay, next kind of like rejoin point normally kind of the yeah carbonyl compound, okay, carbonyl group, okay. Right. So that's yeah easy to recognize, okay. Right. Once you figure it out, okay, so that's alpha micro addition, okay. So immediately find the other yeah alpha carbon in another molecule, okay. So yeah, that should be this guy, okay. No, this one, okay, because this one kind of here more acidic, okay, has 2 carbonyl group, okay. So the folding kind of here pretty easy, okay. Folding pretty easy, okay. So yeah, you can draw the ugly one, okay. Ugly one kind of here the yeah. These two guys kind of here the yeah. The build bond between these two, and then this fourth carbon, third carbon becomes saturated. Okay, so that's the other yeah, yeah, ugly one. Okay, so yeah, actually the product something like this. Okay, right. So, but the yeah, some people kind of yeah, try to do the pretty one. Okay, and then count the wrong number of the yeah carbon. Okay, so yeah, that the yeah give wrong kind of the product. Okay, right. So we build bond between the yeah, alpha carbon and also fourth carbon, okay? So that's the new bond, okay? And then you count kind of the yeah, okay. So quite often the yeah, some students kind of the yeah, either get too many carbon between alpha carbon and also carbonyl carbon, okay? Or kind of yeah, two last carbon only put yeah, two or kind of full, okay? So that's here, okay? That bond need to be on the terminal carbon. As long as on the fourth carbon is fine, okay. So yeah, so for example, okay, so here, okay, yeah, that's here the no terminal carbon, okay. So yeah, I'll give you another example, okay. Right. So that's here the double bond no necessarily kind of in the terminal carbon case. So in the middle case, as long as conjugated kind of here the CT double bond, okay, that will be fine, okay. Right. Okay, so we go back here, okay. So there's one kind of here the yeah way yeah help you kind of here the yeah draw the right here the micro addition product, okay. So we count the carbon, okay, between the two carbonyl group, okay. Right. So this one and this one, okay. So it should be kind of 3 carbons, okay. Okay. 1, 2, 3, okay. So if you are the yeah draw the product, okay, and then find kind of yeah, the yeah carbon between two carbonyl group, kind of 3 carbons, okay. That means kind of pretty much you draw the right here the product, okay, because yeah the one the carbons kind of yeah carbonyl carbon, another 2, okay, from conjugated kind of yeah double bond, C double bond, okay. So yeah, okay. So if you yeah get kind of only 2 carbon or 4 carbon, that's yeah the most time yeah means yeah you draw the wrong compound, okay. So yeah. Okay, so we'll practice more kind of in the discussion, okay? Yeah, also kind of I will give out kind of homework. You can also practice on kind of micro addition, okay? So note hard, okay? Just keep in mind, okay? So first kind of if you see kind of C theta one conjugate kind of CO da bond, okay? So yeah, 100%, okay? That will be micro addition, and then immediately find kind of carbon from another the compound, okay? So you build bond between alpha carbon and also the terminal kind of C theta bond carbon, okay? So that will be kind of yeah, right answer, okay. All right, okay, so now we move to the most difficult reaction in the organic chemistry, okay. Actually, kind of for the whole organic chemistry, okay. Rubinstein annulation, okay. All right, so here I want to little bit the focus on, okay, because each time kind of student get confused, okay, about this reaction, okay, and in exam quiz, okay, so yeah, pretty much a lot of students even gave up for this reaction, okay, yeah. Right, so for Robinson annulation case, so that's actually kind of keep in mind that's the micro addition plus kind of the intramolecular kind of auto condensation case. So that's kind of two tandem reaction, okay. Yeah. Yeah, two reaction. So micro reaction happen first, okay, and then followed by kind of the intramolecular kind of the auto reaction, okay. And so eventually you build up kind of six membrane, okay. So yeah, if the product kind of show the kind of six membrane, okay. So yeah, that's pretty much means kind of you generate kind of right compound, okay. Yeah. Right. Okay. So here's we just use one example to learn this reaction, okay. Robinson annulation, okay. Right. Okay, so this reaction normally you start with kind of the one ketone, okay, one ketone, and then another kind of the alpha beta unsaturated kind of carbonyl compound, okay, yeah, and then for this alpha beta unsaturated carbonyl compound, okay, so there's one kind of it's itself also has kind of alpha carbon, okay, so here, okay, alpha carbon on this kind of alpha beta unsaturated kind of compound, okay, right, okay, so the first, okay, so microdeletion reaction will happen, okay, because microdeletion reaction kind of pretty easy, much easier than any other condensation or kind of Claisen condensation, whatever, okay, right? So that means kind of this cyclic ketone will kind of contribute kind of alpha carbon, okay, to the microdeletion, okay, so that's attack this carbonyl carbon, this actually kind of terminal kind of C bond carbons, okay, that goes here, okay. And then make it kind of saturated, okay. So like I said, kind of 3,4 addition, okay, 3,4 addition, okay. Right. Okay. So once you done this reaction, you generate kind of intermediate, okay. And then you can find quickly, okay. So for this the original alpha beta unsaturated ketone also has kind of alpha carbon, this one, okay. So this one can attack kind of the carbonyl carbon of the cyclic ketone, okay. And then have kind of the auto condensation between kind of two ketone, two aldehyde, whatever. Okay. So that's pretty much between two ketones, okay. And then this one attack here, okay, you generate an auto product, okay. And then following by kind of the condensation, okay, you get kind of 6 bond. That's six membrane, okay, six membrane, okay. All right, okay, and then for this reaction, kind of mechanism actually not required there, but actually kind of not hard, okay. So just kind of keep in mind auto reaction, microdeletion followed by kind of auto condensation, okay. Here's kind of show you another example, okay, show how kind of the Robinson annulation how it's happened, okay. All right, so so first this time kind of we use kind of the diketones, okay, as kind of nucleophile, okay. So base coming, okay, take up kind of the alpha carbons, okay. So and then we generate inlet, okay, and then attack kind of the C theta bond kind of the unsaturated kind of ketone, okay, right? And then you generate kind of the first step product, okay. So they kind of shift kind of the electrons and also protons, okay. So you eventually generate kind of the addition product here, okay, right? And then for this one, okay, so original alpha beta unsaturated kind of ketone also has kind of here the protons, okay, so alpha hydrogens, okay, and then that can be deprotonated kind of base, okay. Right, you generate kind of here the enolate, okay, enolate, okay. So this one can attack kind of here the original kind of carbonyl compound, this kind of diketone kind of carbonyl functional group, okay. And then you close the ring, okay. Generally kind of the adult product, okay. So adult product, okay, eventually kind of the you do kind of the dehydration, okay. So we are generally kind of the alpha beta unsaturated kind of the ketone whatever, okay. So that's the whole process, okay. All right, so just keep in mind, okay, so for the Robinson annulation case, so two-step adult condensation, for microaddition followed by adult condensation, two-step, okay. All right, and then I use another example, show you guys how to draw the product, okay. Okay, still use different kind of color. All right, okay. So we have this cyclic ketone, okay, and then this is kind of the alpha beta unsaturated ketone, okay. All right, so keep in mind, okay, so for this guy, okay, itself also has alpha carbon, okay. Okay, and but the normally the microaddition kind of either than kind of adult condensation, okay. So in this case, the first step, okay, so we have kind of the microaddition happen first, okay. So this alpha carbon, okay, we will tap here, okay. Okay, so probably still use the other. Okay, all right, and then make this two bond kind of saturated, okay. Okay, so we count carbon numbers, okay. All right, and then falling kind of this alpha carbon, okay. We will attack this carbonyl carbon, okay, and then that here we call kind of the adult condensation, okay. Okay, probably. Okay. So eventually you build up kind of two bonds, okay. The one bond, okay, so from kind of microaddition, okay, another bond from kind of is double bond, okay. Adult condensation, okay. This is double bond, okay. So this one, okay. All right. So that's the是零头比的symmetrical, okay. Yeah, right. So that's the final product, okay. Yeah, for the Robinson annulation case, so as long as you keep in mind kind of the first kind of the microaddition, and then followed by kind of the kind of the adult condensation case should be easier, okay. And also the one thing kind of you can keep in mind, okay, count carbon numbers, okay. So count carbon number, okay. So for example, okay, so here, okay, so most important you count the carbon number from this molecule, okay. So 1, 2, 3, 4, 5. Okay, all right. So let's say 1, 2, 3, 4, 5. Okay. After reaction, 1, 2, 3, 4, 5. Okay, and then 6 membrane. Okay, 6 membrane. Okay, so the alpha beta unsaturated kind of ketone contribute kind of the 4 carbons. Okay, and then the original kind of the nucleophile this ketone contribute another 4. Okay, so another 2 carbons. Okay, so that's the 6 membrane. Okay. Okay, so now probably let's see, okay, so probably you guys can practice some kind of easy one, okay. Yeah. So for this reaction, normally you use the sodium hydroxide as kind of the base, okay, because the sodium hydroxide kind of pretty good for the adult condensation, okay. Yeah, take a try, okay, for this here, the Robinson annulation reaction. Probably I still use the colored pen. Okay. Yeah, for Robinson annulation, okay, the first step, okay, so yeah, or the Michael addition, okay. And then the second step, okay, so yeah, you have to try to orientate kind of the molecule, okay. So put here the alpha carbon from alpha beta unsaturated ketone close to the carbonyl group of another molecule, okay. So try to make kind of 6 membrane, okay. All right, okay, so because of time limitation, okay, so yeah, I will show you kind of when I have this question, okay, how do I do it, okay? All right, so that's alpha beta unsaturated ketone, okay, so this one will be the electron file for the first reaction, okay, so that's here the nucleophile, okay. So this one, okay, yeah, another one kind of this here aldehyde, okay, so yeah, was like nucleophile, okay. Attack this carbonyl carbons, okay, first, okay, all right. And then once reaction is done, okay. Okay, so that's the new bond positions, okay. All right. And then this one, okay, so yeah, become kind of saturated, okay. Okay, count carbon number. What we do here? 1, 2, 3, 4, okay. Okay, 1, 2, 3, 4, okay. All right, okay, so that's the orientation. Also help you kind of put the new carbon close to carbonyl of this aldehyde, okay. So that you can build a bond between these two one, okay. All right, and then you can have kind of the aldol reaction, okay. Aldol condensation reaction happen, okay. So eventually lose one water, okay. All right, that's the bond, okay. Yeah, so that's the final product, okay. So eventually kind of you build 6 membrane and then the double bond between the conjugated ketone, the alpha carbon with kind of the carbonyl carbon, okay. So of the origin kind of nucleophile, okay. All right, okay, I guess, let's see, okay, so it's already 50, okay, so next class, okay, we'll do a little bit more practice about kind of Robinson annulation, okay, and then we should able to finish chapter 20 on Wednesday, okay, and then we can also decide kind of Wednesday or kind of the next quiz 6, okay. All right. Okay, so do you guys, thank you, guys, okay, Any questions, okay? Yeah, probably I will give out kind of chapter 20 homework soon, okay, because there's too many, not too many, let me see, okay. So only one reaction left, okay, so that's here the imine as a nucleophile, okay, so yeah. Did you get the chance? Yeah, I'm still reviewing the quiz one now, okay? So yeah, because yeah, on Sunday there's several kind of student kind of yeah, also take the quiz, okay? So I haven't kind of finished, okay? So yeah, if you review me some send me email about kind of some questions, okay? So yeah, I definitely kind of take a look at it, okay? So yeah, don't worry, okay? Yeah. As long as kind of your answer makes sense, okay? So I can give you kind of partial credits, okay? Yeah. Let me turn off the video.